That's my recording. All right, this is 1.1. It just counts down for me so I know when it starts. Our first day of statistics. So yesterday we watched that video kind of explaining about like what statistics is. So I kind of just copy and pasted this out of the textbook here, how it's used in our day-to-day life. It allows us to analyze and make inferences about data so you can be more informed customers, understand statistical studies, and conduct research. It also helps sharpen your critical thinking skills. I think in the video they like mentioned how, you know, stats are like everywhere, and even like what Netflix uses to predict what you want to watch. Like that's all database, that's all statistics. So it's a cool topic and a hot topic. When I was teaching in McGuanago, they were actually adding like a data science statistics class because data was so like such a burning topic right now. Statistics are like everywhere. Okay, so like I said, I don't love this because it's a lot of vocab, but just defining statistics in general. It's basically just like collecting data. So the science of collecting, organizing, analyzing, and interpreting data to make decisions. So obviously the data is basically all the like information that you gain from like conducting like studies or surveys, something like that. This right here, that's just the singular version of datum. You don't see that a whole lot because when we talk about data, it's usually more than one piece of data. So data consists of information coming from different forms of like studies. So observations would be one way we could collect data. Surveys, counts, measurements, responses would be more like a survey. Okay, so probably some vocab you've heard before, but that's like kind of the mathematical definition when we talk about statistics and data. So most statistics are presented like graphically, like this example right here, what Americans know about science. And this is all like based, all of these like statistics here that 86% know the Earth's core is the hottest layer. That's all based on like collection of data. And it's presenting to us all of these like percentages, all these statistics, which we got from collecting all that data to calculate, you know, that 86% of these US adults, and most statistics are presented by graphs, like I said. So really quick, just like story, if you're ever interested in like the field of stats, and I might ask my cousin if she would like come in and talk to us. My cousin is an actuary, and she works for Jack Link's Beef Jerky in Minnesota. So she looks at trends in like data of like what types of like flavors are like selling really well right now, and then she like makes decisions regarding like based on her like collection of like data, like to make predictions of like what customers are going to want to buy in the future. Like that's her job, is like actuary science. So she does a lot of like statistics stuff, and I was like, that's a good example of like how stats are used to like make decisions in her life of beef jerky. And she brings home beef jerky for Christmas all the time. It's great. Okay, so a couple other vocab words that we need to be familiar with, and that's why with this chapter 1, it's just a lot of when we use these to do example problems, and I use the word population or sample, we got to know what that means. So two kind of like types of data here. So when I talk about the population, that means the collection of all possible like outcomes, responses, depending on what type of study we're doing, measurements, or counts whose properties are being studied. So if I was trying to like make a survey of all like the high school students, the population would be every single 9th through 12th grader. That'd be like the population. Sometimes we only take a sample of the population. So if we wanted to like make an inference of like how many U.S. middle-aged women feel something like that. I can't possibly survey every single U.S. middle-aged women, so we just do like a sample of them. So we surveyed 300 U.S. women. So a sample is just like a part of your population, a subset. I'm going to put or part of the population. And that obviously comes up a lot in these types of like studies. Because if we want to make inferences or conclusions about a big population, such as like this one's going to be like the population of the U.S., we possibly can't survey every single person. So here's an example. Samples are generally used to gain information about a population. For example, the unemployment rate for the U.S. population is found by the U.S. Bureau of Labor using a sample of just 60,000 households. So in this case, if I'm trying to make like conclusions or inferences about the U.S. population, that's my whole population. So I'm going to do it in like a little diagram here. My whole entire population of the U.S. And then just surveying 60,000 households, that's just like a little sample of that. Just a little subset of the whole population. Okay. So what we do is we take data from the sample of whatever amount is like being studied. We take the data, we look at the stats, the statistics to make conclusions or inferences, and is another word you'll see come up a lot, or conclusions about the whole population. So we take the data from just like the piece we sampled to make conclusions or inferences about the whole population. Okay, so again, if we want to find the unemployment rate for the whole U.S. population, we couldn't possibly survey the whole population of the U.S. So we just take a sample of 60,000. I put 600,000. Doesn't really matter. Erase one of those. 60,000 households. We look at the data there, and then we can make some inferences about the unemployment rate of the whole U.S. Okay, kind of makes sense so far? Let's try an example problem. In a survey, 834 employers in the U.S. were asked whether they thought, that's what we thought. Typo. Welcome to my life. I have a lot of typos. Where they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population and the sample. Describe the sample data set. Okay, so my population I'm trying to look at all of the employees in the U.S. So it would be responses of all U.S. employees. That'd be my population. That's what like properties being studied here. Well, my sample the part I actually survey here would be those 834 employees. So the responses of 834 employees. And obviously that's just like a part of the whole population of US employees. Okay, so when it says describe the sample set, the sample data set, that's just saying describe the outcomes here. So 517 said yes. Said their jobs are stressful, meaning 834 minus 517 is 317. Said no, their job is not stressful. Okay, we're gonna do one more like that. It's kind of weird. It doesn't really feel like a math class yet, does it? It will. I gotta fix that typo. That's what me. All right, one more. This time, in a survey of 1,501 9th to 12th graders in the United States, 1,215 said leaders today are more concerned with their own agenda than with achieving the overall goals of the organization they serve. Identify the population and the sample. Describe the sample data set. Okay, what do we think for population? Perfect. Good job. The responses of all 9th through 12th graders in the US. What was my sample set? Yep. My sample set was 1,501. 9th. Sorry, I'm writing sloppy. I'm not used to writing this one. 9th through 12th graders in the US. Okay. That was just my sample. So what we do in like statistics is we look at the data here to make inferences and conclusions about like all 9th through 12th graders in the US. And sometimes there's like some bias obviously involved, and we'll get into like all of that. So the sample set here, that would just be kind of like our results here. So it consists of 1,215 agree with that statement, and 286 do not agree with that statement. What do you guys think? Do leaders today, are they more concerned with their own agenda than with achieving the overall goals of the organization they serve?
Not sure.
I don't know. This reminds me, Austin, when you were like out there being interviewed about the mask, is that what it was? Something about like the COVID protocols. You were a part of their sample to try and make decisions about the whole school, right? Statistics in real life. Okay. Some more vocab. We have two like types of data, parameter and a statistic. So a parameter, and this is what your ALEKS assignment is going to be kind of like defining like the difference between a parameter and a statistic type of data. So it's still a numerical description of a population. There's the difference right there. Characteristic. So when you're surveying like the whole senior class, that's a parameter because you're talking about the whole population of the senior class. So you got to look for words kind of like all or the whole A statistic is a numerical description of just a sample characteristic. So if you kind of see, like a survey of 100 freshmen, that would be like a statistics because it's just talking about like a sample of the whole freshman class. Maybe it's a class of like 300 kids. When I was in McGuanago, I think each class was around 400 kids. Isn't that crazy?
Yeah.
Okay. A little added kind of like a difference between a sample and a population. A sample statistic can differ from sample to sample, but a population parameter is constant for the population. Samples are more reliable for making inferences when they are representative of the entire population. Okay, we're just going to kind of try a couple. So this is kind of similar to what you'll do in ALEKS. Is it a parameter or a statistic type of data here? First example, a survey of several hundred collegiate student athletes in the U.S. found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. That's kind of nuts. All right, so is this a parameter or statistic? Is this data a description of all the student athletes or just a sample? Just a sample, just several hundred. So this would be a sample statistic.
Do we have to put sample statistic?
I don't think so on ALEKS. I think you just like check statistic or parameter. Yeah, you don't have to put sample. Okay, next one. The freshman class at a university has an average SAT math score of 514. Okay, did we measure the SAT math score of the entire freshman class or just a sample? Entire, that's a parameter. I'm going to put population parameter, but yeah, you can just do parameter. I thought this would save us time too. You don't have to write out all these problems. All right, last one. In a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature.
Can I swipe your seating chart quick, please?
Oh, sure.
Thank you.
As of yesterday? They're on my
Yeah.
Okay, I'm gonna have to pull them up on here. I haven't printed it out.
Sorry to bother you.
No, you're good. Give us a specific classroom and pull up all.
I'm gonna look through all the schedules I've got here to look at.
Probably adjusting my calc.
AP Calc.
Yep.
Sorry.
Okay, here's that.
That's all I need.
That's all you need? Okay, now it's right here. I let them take yesterday with the new semester, so they changed a little.
As long as they were all sitting there, that's all I need.
Okay.
Yeah.
All right, what do we think for this one? Sample statistics or population parameter?
Statistic.
Sample statistic. Nice. Because you're so smart. Isn't this kind of fun?
Yeah.
It's different.
Now.
Okay.
Oh, not the food. Sounded like I was thinking. I meant the easiness and hardness. That's what I meant.
Okay.
Gosh.
All right, I really liked in the video we watched, I felt like they talked about these two, I don't know if you quite remember these off the top of your head, talked about these like two different branches of statistics really well, or like described it really well. So I'm going to try to kind of like summarize what they said. There's basically like these two different like types of statistics. We have descriptive, which this is our branch of statistics. That involves the organization summarization, and display of data. This is called descriptive statistics. We're going to work with descriptive statistics a lot now, and we'll get to inferential kind of like later on. So as just like some examples of like a descriptive statistics, this would be like any graphs. That's like an organization and display of data. When I calculate average scores, that's data. That's a statistic, right? Specifically a descriptive. Inferential is when we kind of like use a sample data to make a conclusion or an inference about a population in a whole. So this is more the side that like makes those decisions that are driven from data. That involves using a sample to draw a conclusion about a population. This is really common with like probability. If you've ever done a little bit of like probability work in previous math classes, that's kind of like, you know, what is the probability that I'm going to draw a green marble out of this sack that has 24 green marbles, 37 red, something like that. We do this more like in chapter 3. We'll kind of get into, I envision us getting through about like 5 chapters of the stats. It's kind of my goal right now. Chapter 1's pretty short, so. Okay. Those are kind of our different branches, different like types of statistics, if you will. So do a couple example problems like this, practice identifying population and sample again, and then also kind of like drawing what is descriptive from this and what's like technically like inferential statistics. So kind of using like those two vocab putting them into context a little bit. All right, so it says identify the population of the sample, then determine which part of the study represents the descriptive branch of statistics. What conclusions might be drawn from the study using inferential statistics? All right, here's our first example. A study of 2,560 U.S. adults found that of adults not using the internet, 23% are from households earning less than $30,000 annually, as shown in the figure. So here is an example of like a descriptive statistic shown in a form of a graph. Obviously, it's really common. All right, let's start by identifying our population. So you can see here's our sample. We just sampled around 2,560 U.S. adults. My population would be all U.S. adults. Sample would be the responses of 2,560 U.S. adults in the survey. Okay. So let's move on. Which part of this study represents the descriptive branch of statistics? There's a couple here I can think of. The one I mentioned was like the graph. That'd be an example of descriptive statistics. The other one is like this actual like numerical data here, that 23%. Are from households, and abbreviate households. Households earning less than $30,000 annually. That's all descriptive statistics. That's like the data we found. I'm not making any conclusions yet. I'm just presenting the data. Okay, and then obviously you can kind of see from there. So looking at the data, we use like inferential statistics technically to like make a conclusion about like what we notice about this data. So this is U.S. adults who do not use the internet by their household income. So if they have less than $30,000, 23% of them don't. And then you can see as the income increases, there's less and less percentage of adults who don't use internet. So possible like conclusion or inference we can draw here from the data. This is just another like branch of statistics here, is like making these inferences based on the data, based on the numbers, is that lower, and we don't know if this is necessarily true. We were making this assumption for like the whole population from the ones we surveyed, from the sample we surveyed. Lower income households cannot, and there's more than one possible answer, but cannot afford access to the internet. That could be one kind of like reason why this data might be showing these numbers. You could have also said, higher income household internets can't afford access to the internet. Okay, so there's like a good kind of like reference of like the difference between descriptive and inference or inferential statistics. I tried one more of those. We're almost done, actually. This is good. Okay, one more. A study of 300 Wall Street analysts found that the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. So forecasted high-tech earnings, they're kind of talking about like the stock market here of they incorrectly forecasted which high-tech earnings would be in this whatever year they're doing here. Okay. Not a lot of information given, but our population would be responses of all Wall Street analysts our sample, which is the responses of the 300 that were studied. Okay, let's pick out some descriptive here. It's descriptive statistics. The only data really presented to me here is this 44% incorrectly forecasted the high-tech earnings. So that's an example of descriptive. 44% incorrectly forecasted. Now the stock market, that's one crazy thing to try and predict. That's always changing, and it's very hard to
Ireland Bergman to the office, please. Ireland Bergman to the office.
That scares me every time. I mean, we're talking about high-level professionals here. We're surveying Wall Street analysts, and 44% of them were predicted this wrong. That shows you how crazy the stock market is. So a possible inference we could draw here, and again, there's more than one like answer for this, is that the stock market is really difficult to predict, even for professionals. It's difficult to forecast. Okay. There's a majority of our vocab. I just added in like kind of 3 more vocab words that come up a lot. And we're gonna kind of talk about these more in the next lesson, which I'll do tomorrow. When we talk about variables, I mean, you've talked about variables in math before, right? But talking about it in the context of what it means in like statistics. I mean, the nice thing about, you know, a variable in math is like it represents a number, so that kind of like changes sometimes, like depending on what that equation or expression like represents. It's different every time, I guess is what I'm saying. So in statistics, a variable, or maybe we've talked about like variables like in like science experiments too, but it's a characteristic of interest for each person or object. In a population. Okay, that's a kind of like a textbook wordy definition. Basically, an example of like a variable, if I'm talking about like of a person, like their height, something that changes from person to person. Your height is considered like a variable. Your hair color. Those are all just like a characteristic that change from each individual and population. Those are variables. Statistics studies 2 types of variables. Numerical variables, which this is kind of what we talk more about in the next lesson. Numerical variables, which are variables that have like numbers assigned to them or like numerical values. So I'm going to say that take on values indicated by numbers. So something that you can kind of like measure numerically, such as like your height. We measure that with numbers. That's an example of a numerical variable. Your weight would be like another one. Averages. If you're calculating averages, those are all represented by like numbers. That's numerical variables. Categorical variables are variables that take on something other than numbers, like labels. Take on values that are indicated by names or labels. I'll give you some examples. Such as like your hair color. You don't answer that in a number, right? It's a label of brown or blonde. A letter grade, that's not measured numerically. That's measured by like a label. That's categorical data variables, categorical variables. Okay. Sorry, lots of vocab. So while I'm still recording here, I just want to quick explain the homework. And again, guys, if I ever go too fast, I do post the key to this. Your homework is this, Alex. It's like 7 questions assignment. It's basically just like classifying population sample, identifying parameter or statistic. It's pretty fun. I went through and did it. And then I'm going to kind of make for chapter 1, because there's so much vocab, like Quizlets kind of as we go. So like there is this Quizlet. You don't have to look at it like tonight by any means, but I wrote that, or I classified that under the notes section too. And if you want to like do that, before a quiz or something, just know those are always like there for you to kind of like practice the vocab. Okay, I'm gonna stop my recording.